Mount Vesuvius is a volcano in Italy. What was the impact of its eruption in 79 AD? On August 24, 79 AD, a 6-mile chamber of magma far under Mount Vesuvius burst through the cone's plug. The entire top of the mountain blew off. The thriving Roman cities of Herculaneum and Pompeii sat precariously at the foot of the mountain. Over 50,000 people lived in its shadow. A pyroclastic flow, molten rock, poisonous gas, and scalding ash raced along the ground. People died as they tried to run. Buildings offered no refuge. They erupted in flames. In all, over 16,000 people were killed. A column of smoke and ash rose about 24 kilometers. In Pompeii, victims were locked in time by the hot ash, their anguish preserved in molds left by their incinerated bodies. As one witness to the travesty wrote, "We had scarce sat down when darkness overspread us, not like that of a moonless or cloudy night, but of a room when it is shut up and a lamp put out. You can hear the shrieks of women, the crying of children, and shouts of men." Days later, rain fell, setting the ash like concrete, and entombing the city until the 18th century. Today, Vesuvius stands quiet. Tourists wander around the sulfurous vents, but Vesuvius is still an active volcano. Over 750,000 people live in its shadow, including the entire population of Naples. Could they suffer the same fate? The last major eruption here was in 1944. An ash cloud rose 20,000 feet into the sky. The pyroclastic flows reached Naples. Vesuvius sits over a subduction zone and is still dangerous. Scientists continue to study this volcano to anticipate its moves if they can. For now, life under the volcano goes on as usual, at least until the next eruption.
So the destruction of Pompeii there is like of mythic proportions, right? I want you to recognize that the images that you saw there in that video of the people, those are real casts and molds. That's not like some sort of Hollywood trickery. We actually have perfectly preserved sculptures, essentially, of the people as they attempted to try to escape that eruption event. I mean, there was no escape from it at all, but where they fell down and died and then were buried by ash, that material then was filled back in and created a perfect cast, if you will, of the people in the situations and the positions they were in. And they continue to excavate more and more people from that same site. And will it happen again in the future? I would say more than likely. Mount Vesuvius is a very active volcano. So anyway, today we're going to talk about volcanoes, and in particular we're going to talk about what causes the different types of volcanoes, why they erupt the way they do, because there's some pretty big differences between the three main types. And this picture right here that you're looking at is a photo I took out in Arizona. This is a volcanic eruption that occurred, I want to say it was about 1 million years ago, maybe a little less, a few 100,000 million or so. It's pretty recent in terms of volcanic eruptions. I forget the name of this particular eruption. I did not see the volcanoes that caused this, and it's mostly basaltic lava. It's actually Pahoehoe there in the picture of rope lava. It was really cool to run around on. There were areas where there were big holes in the ground, a big magma chamber or lava tubes that lava had flown through and then evacuated and I crawled down into. It was a really, really neat place, and just with the blue skies, it was really cool to kind of walk around in. But let's get into sort of the nature of volcanic eruptions here. So there are three main things that really affect how violent an eruption is going to be. They are the composition of the magma, and remember, magma is just the molten material when it's underground. Once it comes to the surface, we call it lava. Right? So sometimes we use those words a little interchangeably, but truthfully, magma is when it's underground, lava is once it's reached the surface. So the composition is really important. We'll talk about that here in a second. The temperature of the magma, how hot it is, which is also determined in part by the composition, determines how it erupts. And very, very importantly, the dissolved gases. How many gases are dissolved in the magma and how quickly can they get out of the magma? That will determine how explosive an eruption is. And as we're going to see, the differences in temperature and composition really determine in large part how easily those gases escape, so how many of them there are in there. Let's start with viscosity here. When we talk about viscosity, what we're talking about is it's a measurement of the material's resistance to flow. So a fluid that moves, that flows, like water or syrup, if you will, on your pancakes, has a viscosity, how easily it actually flows. And a more viscous material with a higher viscosity, sorry, will have a harder time flowing. So if I were to say, turn upside down a container full of water versus a container full of maple syrup, the maple syrup is more viscous, so it would kind of slowly drip out of the container versus the water, which has a very low viscosity, would just dump right out really fast. All right, so try to keep those sorted out in your head. I'll show you this slide here. It will help you kind of remember a little bit, and maybe answer one of the questions on the quiz. Viscosity is affected by the temperature and the composition of the magma itself. So a hotter magma is less viscous. It makes sense, right? If you get some material really hot, it flows easily. Think about even, say, like syrup or something like that. If you heat it up, it moves more easily, versus if you put it in the freezer and cool it off, it's going to be very, very hard to pour. So the hotter the magma, the less viscous, the less thick it is. So if you want to remember viscous means thick, maybe that helps, okay? The composition also determines this, mainly because of the difference here. A higher silica content magma melts easier, okay? So a higher silica content magma will have a higher viscosity because it melts easier, so it doesn't have to get as hot. If that sort of makes sense a little bit. So either way, remember, a higher silica, that's like quartz, equals a higher viscosity, has a harder time flowing. And what that means is that if a magma has a lot of silica in it, it's going to be more likely to explode because it's going to be thicker. It's going to have a hard time oozing out. It's just going to blow up. An example of that would be a rhyolitic lava. So rhyolite is a type of rock that we studied. If you remember, it's that whitish, pinkish colored rock that is formed from these high silica content lavas. A low silica content lava would be like a basaltic lava, that really dark colored rock that you saw at the beginning of this presentation. Just a couple slides back, I had that picture from Arizona, and that's basaltic lava. It flows. It made those kind of rope-like, flowy, sort of textured looking structures. It doesn't tend to explode. It's very fluid. It doesn't have a lot of silica in it. Now, the reason for that, I don't want to get too complex here, but it has to get a lot hotter to melt because it doesn't have as much silica. And if it's hotter, it flows easier. There you have it. So high silica, high viscosity; low silica, low viscosity. Let's move on to dissolved gases. There are two main gases that are found in volcanoes. There are other gases, for sure, but the two big ones that come out of the top of a volcano are water vapor and carbon dioxide. All that white smoke-looking stuff that you see coming out of most volcanoes, pictures of volcanoes, The majority of it is water vapor. You're probably wondering, how in the heck does water get into a volcano? Well, water is actually locked up deep in the earth inside the rocks themselves, and as they get heated, that water starts to expand and vaporize. Okay, so there will be water content that's released, tremendous amounts of it that's released out of a volcano. As those gases get near the surface, they expand, and that can be very explosive. We've got a term here called a vent, which is just the opening at the surface that the gases in the molten rock are expelling out of. Okay, so the main force that pushes the lava out is those dissolved gases that are inside the lava. You can think of it kind of like a soda bottle. If you shake it up, there's a bunch of dissolved gases in there, and you open the lid, all of those gases come out of solution and erupt out of the top of it. It is very similar to how a volcano actually goes off. Now, like I just said, the violence of an eruption is really related to how easily those gases can get out. If they can get out easily, then you've got a very fluid magma, and it flows really easily out. It's not very violent. But if they're trapped in there, it's very thick, and those gases can't get out of the magma, you're going to have an explosion. Looking at a chart here, comparing the different types of magma compositions, we can kind of generalize based on the three main types of rocks that you get out of a volcano. We have basaltic material, andesitic, and rhyolitic, and you might remember some of those from our rock unit. So those rocks are essentially rhyolite being very, very rich in quartz and silica, basalt having very little silica in it whatsoever. It's more mafic, it's magnesium and iron based. It's very dark colored, and andesite's kind of somewhere in the middle. Okay? The reactions you get when those things come out of a volcano can be very, very different. Let's just look at the viscosity there. The one with the least is basaltic. That's why, if you look over there, it has very few pyroclastic fragments. Not a lot of stuff blows out of the top of a basaltic volcano. These things tend to form shield volcanoes, like in Hawaii, basalt plateaus in the case of really big, giant eruptive areas, and cinder cones, which do have some pyroclastic material. That's kind of what they're made up of, but not big stuff that really doesn't get blown out of them. It's all these tiny little cinders that come out. I'll show you some pictures here. Andesitic, like I said, is somewhere in the middle, and that tends to form some of these composite cone volcanoes, as well do rhyolitic materials. If we look there towards the amount of pyroclastic material that comes out, the rhyolitic composed volcanoes have the greatest amount of ejected rock stuff. That's what pyroclasts are. Clasts are rock material, like individual pieces of rocks, and pyro, meaning like fire to explode. Okay, so that's rhyolitic stuff is the most pyroclastic. As we turn to lava flowing, that's typically basaltic lava that we're talking about. It's more liquidy, it's more fluid. It has a low viscosity. And there's two general types of lava flows that are from basaltic material. And we could see both of these in Hawaii today. Pahoehoe lava is stuff like I showed you in the beginning there that kind of resembles braids of rope. So it's like it flows and it kind of rolls on itself and kind of makes little bunches. It's really kind of beautiful looking stuff. And then there's this stuff called aa, which feels just like it sounds. It's these rough, jagged blocks of material that form on top of a cooling melt. Those two words are both Hawaiian, by the way, and we use them throughout geology. And they are, like, aa sounds almost exactly like what it looks like. It's kind of funny that it's that way. Maybe that was the reason that they called it that. Because when you stub your toe on the stuff, you go, right? So gases in these types of lava flows are pretty low. Of course, mostly water vapor, carbon dioxide again. That's pretty much standard for any lava, any volcanic eruption. Let's look at some Pahoehoe, the ropey lava. Here's a photo of some, almost exactly like I showed you. It's actually flowing there, and you can kind of see how as the surface cools, it kind of braids up and makes like these rope-like looking structures. It almost looks real syrupy. It kind of is syrupy. in a way. But when it all cools off, it makes these cool little flowy rope-like structures. When this stuff flows out into the ocean, by the way, let's say it doesn't make it, it comes right out of the volcano and right directly into the water, it forms something called pillow lava, which kind of looks like similar, mostly big balls of big pillowy things underneath the water. It's really cool. As it forms, and also Pahoehoe, are very slow-moving lavas. Like you can literally just walk away from this stuff. And here we are in Hawaii with two people demonstrating the fact that a basaltic eruption oftentimes is so slow, you've got plenty of time to get away. There's really no worry. So when we were looking at Mount Vesuvius erupting in the very first video that you just watched, that was not a flow like this at all. That was a very different pyroclastic type event. And this stuff, you can look at the top of it there, it's all crunchy and broken up looking. That's when it all cools off, it'll look like that. But that is destroying everything in its path, right? And they have problems with this in the Hawaiian Islands where they have to, when an eruption happens, they have to then go through and clear all that off the road. Imagine how difficult it is to break rock away from a road and then haul it off someplace. But at least it's not moving fast enough that it's really going to, catch you. You can walk away from it. Let's look at some pyroclastic materials. And like I said before, that's anything that gets ejected like up into the air out of the volcano. And this stuff can be really small, all the way down to stuff like ash, like millimeter size-ish stuff that kind of rains down and even stays up in the air for a long period of time and blows far away and lands maybe hundreds of miles from the actual eruption, to stuff that's really large, like several tons. We're talking about material that is bigger than your vehicle, bigger than your car, falling out of the sky. Can you imagine being near something like that where the volcano erupts and then cars fall out of the sky, car-sized rocks that are, of course, molten? So like literal hellfire raining from the sky. Pyroclastic materials are really neat, by the way. I think they're really cool. So here's a list of the different types of stuff that we see, kind of organized from smallest to largest, if you want to answer that question on your quiz. Ash and dust are the finest, and volcanic ash, by the way, is actually glass. It's volcanic glass, and so is pumice. It's terrible stuff to breathe, right? That's why you see pictures of people near volcanic eruptions and they have materials over their face, they have masks on, they're trying to cover up with whatever they can because that ash gets into your lungs, and not only is it glass in destroying your lungs, but after it gets moistened by the moisture inside your lungs, it essentially hardens back into rock again like cement. It's terrible, terrible stuff to breathe. It clogs up everything, clogs up airplanes, they can't fly, they'll fall out of the sky. It clogs up ventilation systems. It's some nasty stuff. Pumice is larger. It's bigger, chunkier stuff, and it can be sort of lots of different sizes. Anything from I'd say like baseball-ish size, maybe a little bigger, all the way down to some really tiny little pieces, and it's all kind of little pocketed, air-filled particles. And it floats on water, which is really pretty cool. It has so much air pockets in it, but it's technically a glass. Lapilli are harder walnut-sized particles that fall out of the sky. And then we have cinders, which are more pea-size-ish stuff that make up cinder cone volcanoes. I've seen it a little bit larger than that too. And then stuff that's bigger than all of these, we call blocks and bombs. How is that for some terminology? It's very descriptive. Blocks are the stuff that falls that's hardened up in the sky. And like if a rock on the side, a large rock on the side of a volcano gets shot up into the air, that would become a block. Bombs are stuff that get ejected as actual molten lava. So it shoots up into the air, it is burning hellfire up there, and as it falls, it begins to cool, and usually they cool before they hit the ground. They don't have to, and those are called bombs. And I'm going to show you some video of some bombs here in just a second. Let's actually do that right now. This is a photo from 2017 of a famous volcano in Iceland, known as, I'm going to do my best here, Ayaskatleukuk. Ayaskatleukuk is the name of the volcano, and it is not spelled anything like that. If you know anything about Iceland, Icelandic language is the closest language that there is to the actual original Viking language. So the pronunciation, pretty tough. It doesn't look anything like it's spelled. But anyway, this volcano erupts very regularly. I think it's like something like every 35 years or so, but it's erupted more frequently in the last couple of cycles. So this is 2017. This one here is the eruption that took place in 2010. This is November 5th, 2010. And this thing is a doozy. It sits right on top of the Ayaskatleukuk glacier that I actually got to walk on when I was in Iceland. It's an amazing glacier. But this thing, when it erupted in 2010, actually it shut down 20 European countries' air travel. Like, this cloud of dust got shot so high into the air, and where Iceland's situated, it's directly underneath the Gulf Stream or the jet stream, and the jet stream picked it up and blew it all the way across, covered Europe. They had beautiful sunsets, beautiful sunrises. Airplanes couldn't fly. Like, literally shut down 20 European countries traveling anywhere for 6 whole days. Nobody could travel. Like, shut down that part of the world. It's crazy. Of course, that blew towards the west, so it didn't affect the United States really at all. When that thing went off, it was under about 660 feet of glacial ice. So there's a glacier on top of most of that, and the explosion, because of all that ice trapping it in, that hot steam from all of that, just shot it so high into the air. Now I'm going to show you a video of this eruption, and you're going to see some beautiful images of bombs going through the air, and it's just spectacular. These things, like, shooting across, they look like meteorites coming through the air, and you're going to see some people walking out on a ridge. I don't think this was the first day of the eruption. Those guys were out there. It erupted for a couple of days, and nobody actually died during this eruption, which is surprising when you see just how close these guys are to standing next to this thing. It's kind of disturbing, but check out the bombs. They're really pretty cool. Look at those guys standing right there on that ledge. Look at that. Look at those bombs flying right through the air, right past them. I mean, they're right there. It's crazy. I like the last image there of them retreating off of that little little ridge that they're standing on. It's like, time to get away, right? So let's look at the types of volcanoes. There are 3 main types of volcanoes, and we'll go over all 3 here. There are what are known as shield volcanoes. There are cinder cone volcanoes, and there are composite cone volcanoes, sometimes called stratovolcanoes. So the volcano itself is the raised area that's formed on top of this eruption, right? And I think most of us realize that. It's made up of the stuff that comes out. Now, sometimes a volcano will develop what's called a crater, and that's also a similar term we use for a big hole in the ground that when a meteorite strikes, it also creates what's called a crater, but this is a little different. So those craters are these big depressions at the very top of the volcano, and sometimes they'll actually fill up with water, and you'll have a little crater lake up at the very top. But those are known as caldera lake as well. So there is a conduit, a pipe of material that flows up to the surface and erupts out. So sometimes, even long after the volcano's been worn away by erosion, that pipe will still be standing there, and you can see where there was an ancient neck of a volcano. But let's take a look at kind of the anatomy of a typical stratovolcano. And you can see the layering here of various pyroclastic material interbedded with lava flows down the sides of the volcano, and it kind of builds itself up as it flows, right? See the conduit pipe there, the vent at the top, that crater, and they'll erupt out the sides too. You can see little branching things happening. In the case of Mount St. Helens, its main eruption was kind of out the side of the volcano, and it blew off most of the mountain. We'll take a look at a photo of that as well. So let's start with shield volcanoes. A shield volcano is a rather broad, like really gently sloping volcano made up of these fluid basaltic flows. So they're flatter than any of the other types of volcanoes, and they're usually pretty large because the stuff just erupts out and runs outwards. So this is essentially what all of Hawaii looks like. All the Hawaiian Islands are essentially just large shield volcanoes. Compared to a cinder cone, usually you find cinder cones in these like groups, little clumps of them all together, kind of nearby, and they look like perfect little cones. And there's all these tiny little pieces of ejected pyroclastic material, whether it's little bits of pumice or little cinders, little bits of stuff that make them up. Walking up the side of one of these, it's kind of like walking up a big mound of like thick sand stuff. It's real gritty and it slides, and it's very hard to walk up. They're very steep. The angle's really steep. But they don't tend to get really, really large, either wide or tall, because they're made up of all these little bits that kind of spit out of them. Looking here at a shield volcano picture, you can see how long and wide that thing is, right? So you've got like a magma chamber underneath there, some vents that are opening up near the top there, a flank eruption, the central vent, the top of the summit there, where the caldera is, where the big opening is. That's kind of a drawing of the picture that you see in front here. Okay, so they're very, very large structures and flat, very flat compared to these other. Here's a cinder cone, and they look like almost perfect. That's maybe not the best picture of one. They're like perfect little volcano like cones is what they look like. They don't get very tall, but they're made up of all these little pyroclastic fragments down the sides. They look like almost like little anthills is what they look like, honestly. Now let's turn to the last type, called a composite or a stratovolcano. These are the most violent types of volcanoes. These are the ones that explode, that are very, very dangerous to humans and everything else around them. They're composed of alternating layers of lava flows and pyroclastic materials. So you've got a situation where sometimes some flowy stuff comes out, and other times explosions happen. So an example of this would be like Mount Rainier, Mount St. Helens, I think Vesuvius is an example of this. They're very common throughout the world, and they can be very, very large, and they are the most violent. Take a look at one here. Yeah, so a lot of the time you might look at a picture of a composite cone volcano and think, oh, it's just a tall mountain. Well, they are really, really tall mountains, but they're actually volcanoes. So here's Mount St. Helens, both before and after the eruption that happened in 1980. Famous, probably the most famous eruption that's ever happened in the United States in recent times. And when it occurred, I was a kid, and some friends of ours actually brought me back some ash because it was literally everywhere. You could just scoop it up out of the roads. But the entire side, if you look at the original pictures, it's a nice kind of perfect peak cone-shaped sort of structure. And then in the second picture, you can see that the lake is like filled in some. There's ash all over the lake, and the whole side of the volcano is missing. It literally blew that whole side off. Also notice the trees. It flattened every single tree and scorched them nearby. So it just demolished the area, and it was violent and it was quick. Looking at the profiles of these various volcanoes, you can see the size. Look at, I mean, like as far as width goes, Hawaii is huge. It's a huge shield volcano, right? Cinder cones are itsy bitsy little things, yet composite cones aren't as wide, but they're very, very tall. Okay, let's take a look now. I want to show you this because it happened very recently. Here's a photo of a stratovolcano. Okay, so a composite cone volcano. It doesn't look very cone-like, yes, but it's had its top blown off a few times. It's very active. This is on White Island, or if you want to speak the Maori for it, it's Waikiri Island in New Zealand. And New Zealand itself is a very volcanic place. I was just there very recently, but this is in 2019, December 9th, 2019. There was an eruption here, and it was really traumatic. I don't know, you might remember this one. It was in the news a lot. It's still in the news because there's still prosecution pending for this thing. So this island is a very big tourist spot. Like people want to go there by boat. It's not very big off the mainland, and they want to experience a volcanic landscape where you can see gases like billowing out. So this is how it looks when it's not erupting. This is just the regular old, every old day White Island going on about his business here. There's nasty sulfur gases and things coming out of that thing. You can't get too close to them because you'll get dizzy and pass out. But you can walk around, and there's a couple of tour companies that take people out here. Now, December 9th of 2019, there was a huge eruption, and it was violent and it was fast. There were 47 people on the island at the time, and 22 people died. It was really tragic. All of the survivors, except for maybe like one or two, were horribly burned and had to have all sorts of skin grafts and be in the hospital for months. It was really, really tragic. It took them a very long time to even find all the bodies from this thing. But it's a complicated situation in New Zealand because New Zealand has what they call no-fault insurance. So essentially that means that you're not allowed to sue a travel company for negligence or something like that if you do something with them and you die. But think about New Zealand. It's a very different sort of place than the United States. It's the birthplace of, say, of bungee jumping. They've got a lot of canyoneering. They are into, like, really into adventure, high energy sports, in alternative type sports that a lot of the rest of the world looks at as like highly dangerous. That's sort of the day-to-day in New Zealand. Very cool place in my book. Where else can you go someplace and experience the first bungee jump location that was ever done, right? Off of a bridge in southern New Zealand. But anyway, this thing erupts, and then there's tour boats, of course, kind of nearby, and I think you can maybe see a few in the picture here. Near the coast there's two little white dots. Those are tour boats. The landing site is that flattened area on the right side of the island there. It's the only place you can land a boat and get off. And they're going by, and the thing erupts. I mean, it just goes off. And people don't know what to do because they've never seen anything like this. Nobody's expecting it. And then a couple of the boats realize that there's people stranded on shore, and so they send over lifeboats really quick to pick up as many people as they can, and that's how they were able to rescue some of those folks, and they only lost 22 people. So some people were way inside of that thing when it erupted, and they were dead instantly. Like, there's just no doubt. There would be no surviving that. What kind of situation do you have during an eruption like that? Well, you not only have all of the earthquakes and everything that are shaking the ground, making it impossible to stand up, but you have gases erupting out of this thing that are toxic, like sulfur dioxide, carbon dioxide. You can't breathe that stuff and live. Like, you just pass right out. You're done. And then on top of that, you have scalding hot gases and pyroclastic flows, like ash and stuff, that is hundreds of degrees hot, that just burns all of the flesh off your bones as it comes by. Like, everything in its path is just melted. So the folks that did survive were kind of on the edge there of the island, and they were all picked up and drug off really quickly. And it was 2 weeks, or it was a week after the eruption before they could actually make landfall again to check for any survivors. And everybody knew there wasn't any survivors. I mean, there was no chance. But it was a week later, because of all the shaking that was still going on, they weren't able to actually get onto the island because of the toxic gases. It was actually raining as well. It was a real mess. Now, why are they prosecuting the tour companies? Well, the tour companies kind of knew, because 2 weeks before this eruption happened, there were some new volcanic tremors, like increased volcanic tremors, which are a precursor to an eruption. They can be, they don't have to be. It's very difficult to predict a volcanic eruption. However, there are some telltale signs, and volcanic tremors are one of those, harmonic tremors. There was also increased sulfur dioxide content in the air. They test this stuff like daily there to see what's going on. There was a magnitude 5.9 earthquake that happened in those 2 weeks. So the GeoNet, which is their like geological society, actually raised the warning level about the island in the 2 weeks before this happened. So the tour companies kind of knew. So were they pushing the limits a little bit? Yeah, probably. But chances were good that it wouldn't really be anything at all, because like it's a volcanic island, right? So where does the fault lie? You've got to kind of take that into account when you're like, I'm going to go visit an island that is an actual active volcano. Like there's no guarantee that it won't just erupt. Like you have to be smarter than just putting your life into the hands of some random tour operator. You've got to recognize that there are real risks, and maybe you're not just necessarily going to be protected because somebody said it was okay, right? I mean, you have to know a little bit about geology if you're going to visit an active volcano. So anyway, it was really tragic, really horrible, and I want to show you guys some images here. It's not too gory or anything, but you will see, if you look very closely, it'll sweep by pretty quick. You'll see a real quick picture from a webcam that they have inside the crater of folks that were hiking in there, and they're not around anymore. I mean, there's no way that those people escaped from inside of there, because one picture will show the people in there in the crater, and the next picture is completely just covered in white ash. It's just gone. But it's pretty shocking stuff, so I'll let you guys check this out here.
I know there will be a huge amount of concern and anxiety for those who have loved ones on or around the island at the time, and I can assure them police are doing everything they can.
So definitely a really tragic event, and pretty scary. But yeah, it's just, volcanoes are a real thing, just because we don't see them in Indiana, right? So anyway, go ahead and submit your quiz, and that's it for today.